Emerging digital culture in contemporary society has driven the need to master technological skills. This transformation in education arises through the crucial role of digital technologies in fostering vital learning outcomes, including the development of 21st century skills. Furthermore, Kong argues that in order to develop the capabilities characteristic of 21st century skills, educators must incorporate digital technologies into curriculum. This lesson sequence has been developed in adherence to Mishra and Koheler's technological, pedagogical, and content knowledge framework. The TPAC framework provides teachers with a mental model visualizing the complex relationships between the different domains of their knowledge.
Moreover, the framework provides teachers with meaningful opportunities to design and implement instruction that is responsive to the needs of all students. Furthermore, the literature argues that the TPAC framework makes the teaching and learning of coding in particular more efficient, effective, and engaging for students in classrooms. The literature defines technological coding as a precise set of instructions that provide directions to a technological device, such as a computer, through input of algorithms to receive a desired outcome or output. When students learn to code, essential skills such as problem-solving, innovation, logic, and critical thinking are developed. Furthermore, coding skills have been developed in the lesson sequence through the employment of computational thinking. According to Akara, computational thinking refers to the problem-solving process by which various strategies and approaches are implemented by digital systems to formulate a problem and express a solution. The process draws upon logical reasoning through decomposition, pattern recognition, abstraction, algorithm design, and debugging. Furthermore, the stages of computational thinking have informed the development of the lesson sequence.
The first lesson in the sequence provides students with a contextual understanding of the content aspect of the unit, a key component of the TPAC framework.
Firstly, decomposition, according to Krauss and Protzman, provides a robust foundation for understanding problem-solving challenges in coding.
This stage of the lesson has been developed aligning with the literature's suggestions for decomposition strategies, whereby students begin role-playing the directions set aloud by the teacher and their peers. Secondly, pattern recognition is a prominent component of computational thinking highlighted in this lesson. Students are provided with an oral and visual sequence of stages that require recognition before abstraction, as supported by Morris, Uppal, and Wells. The second lesson in the sequence introduces the technology aspect of the unit, in which pedagogical and technological knowledges are intertwined as a part of the TPAC framework. In this lesson, students are exposed to the stages of computational thinking when creating solutions to simple coding or programming challenges in adherence to the technology content descriptors. For instance, students adopt role-playing strategies to decompose the challenge before recognizing a pattern and designing an algorithm to be entered into the iPad, programming the Bluebot to move to the desired location. Finally, the students debug their algorithm if problems arise during the creation of their solution. Furthermore, the literature argues that this is an effective method of integrating computational thinking in classrooms to develop students' logical reasoning and problem-solving skills by breaking down the challenge. The third lesson in the sequence combines the content and technological knowledge aspect with pedagogies as part of the TPAC framework.
Computational thinking is employed when creating solutions to coding challenges in adherence to the technology's content descriptor. For instance, the students and teacher works collaboratively to decompose the challenge by role-playing.
After moving through the stages to design an algorithm to solve the digital challenge, students work on debugging their code. Within this lesson, an opportunity is provided to students to debug their algorithm based on the teacher exemplar to identify where mistakes were made if required. This task highlights the importance of debugging when coding to students and is followed with an explanation as supported by Krauss and Potzman. This activity places a strong emphasis on the stage of debugging and as a result will be observed for formative assessment. The fourth lesson in the sequence also combines content and technological knowledge with pedagogies as part of the TPAC framework. The summative assessment enhances students' knowledge of coding and facilitates computational thinking in adherence to the technological and mathematical content descriptors.
For example, students work through the stages of computational thinking to devise a code that programs the Bluebot. Students will decompose the activity using knowledge of this computational stage through pedagogy such as role-play to break down the problem. Students recognize a pattern by breaking the problem down into components and stages.
Students then abstract the problem by transforming the pattern into its form before designing an algorithm. After breaking down the problem, students design an algorithm of steps for the Bluebot before debugging and redesigning the algorithm. Overall, the technological, pedagogical, and content teaching strategies that have been employed throughout this lesson sequence have been supported by the literature to enhance students' knowledge of coding and facilitate computational thinking.